All right, guys. So let's look at the review sheet because y'all have the test tomorrow. Any questions on problems 1 or 2?
Yeah, I don't care which one.
So factor each completely. So one of the big things that y'all will need to be looking for, let's get the stylus out, is greatest common factor. There we go. Greatest common factor. Because so far, especially with the homework, I've been a little lenient. I've given y'all at least one mistake or error somewhere that I didn't count off at all. And I haven't been too picky about the greatest common factor, because if you forgot to factor it out, I wrote it in on the worksheet, but I didn't count off for it. On the test, the greatest common factor, if there is one, will be worth a point. So most of them are all out of 5. So if you get it factored down, but not completely with the greatest common factor out, you can get 4 out of the 5 points. But if you do remember to factor it out, you will get the full 5. Will every one of them have a greatest common factor? Well, no. But if it does, there's an additional point attached to it. So we look at this first one here, 6a cubed b squared minus 36a b squared plus 71a squared b squared. We know for certain between these three here, there is a greatest common factor, because they all have a and b. Now, when we look at it specifically, because the first term is a cubed, the second term is a, and the third term has a squared. So the most a's we can take out of these three here is 1. We can just take out a. Now, the other one, we have b squared, and b squared. So we can pull out b squared. Is there any other greatest common factor? No. It's very tempting to say 3 or 2. Well, 6 and 36 have several greatest common factors. But 71 doesn't have 2 or 3, which are the main ones with 6. So that doesn't work. So we can factor out ab squared. Now, ab squared factored out of 6a cubed b squared. We'd still have the 6. A squared, because a cubed, if we remove 1, will be a squared. Minus, well, the 36 will stay the same, the negative will stay the same, but a and b squared will both be factored out completely. Plus 71. If we factor an a out of a squared, we're left with a, and b squared factors out completely. Okay, I'm going to rewrite this. So I rewrote it so that it is in standard form. The variables go a squared a in our constant term. Now, because the 36 is negative, our signs are going to be, one's going to be positive and one is going to be negative. Now, the factors of 6a squared and 36 are what we need to find next. Now, I know that a squared factors to a and a. Now, the factors of 6 are 1 and 6, or which one do we want to start with? 1 and 6, because the middle term, 71, is pretty big. So we can go 6 and 1. or 1 and 6, because again, we're going to check this in the end. 36. 1 and 36. 2 and 18. 3 and 12. 4 and 9. 5 doesn't work. 6 and 6, and we're done. Which one do we want to try first? We can. But did we have a greatest common factor to begin with? Right, there's no greatest common factors here. Well, 6 and 2 can't go in the same set of parentheses, because then we would have a greatest common factor. Yeah, so 6 and 6 wouldn't work, because there would be a greatest common factor. Well, yeah, either one. Either one of these. 6 and 6 would not work. So 2 and 18 won't work for this one here. And if we tried flipping it, well, still wouldn't work. But we still want something pretty big, yes? Okay. Well, 3 can't go here. So that's, okay, so we can try 12. 12 can't go either. That's way too big, and we can't go the other direction either. So let's try it. 6a times 9 is negative 54 plus negative 50a. Well, that doesn't work. Well, let's just check something here. Square root of b squared minus 4ac is 64.6297. So that there's as far as it goes. So it is factorable, but the only factors that we have is a greatest common factor. There isn't anything else that we have with it. Okay. But that's all we have to do for this here. Now, there's only one that shows up where we do factor something on the test, and the variables do have a power greater than 2. But most likely it will be a little bit more obvious than this one here that you're done. But the rest will be factorable in some way, shape, or form, to where we're not sitting like this here trying to figure it out. There's not going to be one that is not factorable at all, where you can't pull a greatest common factor out or factor it in any way, shape, or form, like on the first homework, where we just had to say not factorable. Does that make sense? Okay. Questions on number 2? Because number 2 is a difference of perfect squares. Because 36x squared would be 6x times 6x. And 7b times 7b, yes. So this here would be 6x minus b times almost plus 7b. Because the difference of perfect squares, one's going to be minus and the other is going to be plus. Questions on this here? Questions on 2, or the second 2 or 4? Second 2 or 3? Y'all want to look at either one of these here? You feel comfortable with these two? Questions on 4 or 5? Okay. So if we look at number 5, we're going to look for a greatest common factor first, because that's the first thing we do need to look for. And if we look between these three terms, well, there's not a number that will go into 6 or 8, 6, and negative 27. So we'll do our 2 sets of parentheses with 3 spaces. Now, since the third term is negative, our signs are opposite. One's going to be positive and one's going to be negative. So now we need to look at the factors of 8x squared and 27. Well, the factors of 8x squared will have x and x. Don't know why it switched colors. Okay. Now the factors of 8 are 1 and 8 or 2 and 4. Factors of 27 are 1 and 27, 3 and 9. So for 8, which ones do we want to look at first? 1 and 8 or 2 and 4? 2 and 4. Doesn't matter where we plug them, we can do 2 and 4. For 27, do we want to use 1 and 27 or 3 and 9? Okay. So let's check it here, and most likely we will need to flip the signs. 2x times negative 9 is negative 18x. Plus 12x is negative 6x, but we want it to be positive. So we change it from flip the signs, which would make it positive. So the correct answer would be 2x minus 3 times 4x plus 9. And that'd be it. Any other questions on number 4 or 5 before we look at 6 and 7? Questions on 6 and 7? 7. So if we look at 7, we want to see if this is a sum or difference of perfect cubes. Well, we can take the cubed root of a cubed, which is a. Now the cubed root of 1 is 1. It actually works out that the nth root, any root of 1, is 1. So this is a sum of 2 cubes. Now we can draw the tractor trailer for what I think of as the tractor trailer. Small set of parentheses, big. Now our signs are going to be the same. Opposite always end on a positive note. So since we started out with a plus, they're going to be the same. So plus, opposite is going to be minus, and always end on a positive note will be plus. So no matter which sum or difference of perfect cubes we have, we will always have 2 addition signs and 1 subtraction. Now we'll plug our terms in. Since a cubed was first, it's going to go first. So in the first set of parentheses, we will have a. And that's all, the only place it appears in the first set of parentheses. In the second, we're going to have a squared, then a to the first, and lastly, we would have a to the 0. But anything to the 0 power is 1, so we don't have to put it in. Our other term is 1. Since it came second, it goes second. So we'd have 1. With a squared, we would technically have 1 to the 0, and anything to the 0 power is 1. And then in the middle, we'd have 1 to the first. And lastly, we would have 1 squared. So what we end up with is plus 1 times and that's it. Any other questions on these two here? We have it right here. 20. 20 questions. And a bonus. Any questions on 8, 9, 10, or 11? One of these that y'all want to look at. 8. 8x squared minus 72. Well, 8 is not a perfect square. And 72 is not a perfect square. So what do we need to look for? A greatest common. Is there a greatest common factor between 8x and 72? 8 times what is 72? So 8 will go into both. So this would leave us with x squared minus 9. Now x squared minus 9 is the difference of perfect squares, which would factor to what? X plus 3 and and that would be the answer. So the real key for that one there was finding the greatest common factor. It would be very tempting to say 2. Because if you had factored out 2, it would have worked as a difference of perfect squares, because we would have been left with 4 and 36, but we would have still needed that other greatest common factor to come out. Any other questions on these three here? 11. So when we look at 11, we have x to the fourth, x cubed, and x squared, 49, 343, and 7. Well, looking at the numbers, I do know that there's a greatest common factor between 49 and 7, which is 7. It'd be nice if 343 was divisible by 7. And it is. So we can factor out a 7 and an x squared, because all three terms do have x, and whenever we're factoring out a term, we're really taking the smallest number of the group. If we're talking about variables with exponents, well, the smallest one is x squared, so we can factor it out. If we factor 7x squared out of 49x to the fourth, squared, because 49 divided by 7 would be 7, and x to the fourth divided by x squared would be x squared, because we take 2 away. Plus, 343 divided by 7 is, and it'd be 49x, because we have x cubed and we take 2 away. It'd just leave us with x. Plus 1. 7x squared divided by 7x squared would be 1. Whenever something factors out completely, the only thing we have left is 1. And that is it. There's no way that we set this up will give us a middle term of 49. Because we could try plugging this into the calculator, taking the square root of 49 squared minus 4 times 7 times 1. And it would tell us that that is 48.7134, non-repeating, non-terminating decimal. So that there would be our answer. Because the only greatest common factor that comes out is 7x squared. Any other questions on 11? Questions on 12, 13, 14, or 15?
Well,
13? So what we want to do is check and make sure we can take the cubed root of both terms, 375a cubed and the cubed root of 192b cubed. Well, we can for our a and b. Now the 375, okay, so both of those come out as a decimal. So what we need to look at now is to see if there is a number that goes into both of these here that would reduce it down into a perfect cube. 3. So we factor 3 out. 375 divided by 3 is going to be 125 a cubed plus this here is going to be 64 b cubed. Okay, well that's going to definitely work. And the reason I know that works is, well, we've had 125 and 64 appear a lot over this last week. Now, since the sign starts out as plus, our first one is going to be the same, so it would be plus, and then negative and plus. Seems I got a little overzealous on putting spaces in the second one. Now we need our two terms. Well, the cubed root of 125a cubed was, because the cubed root of 125 is 5, and the cubed root of a cubed is a. So we'd have 5a. In the second set, we would have 5a squared and 5a, and the last one would be 1, but we're not going to put it in. Now for 64b cubed, well, its cubed root of 64 is b. In the middle one, we'll have 4b, and in the last one, we'll have 4b squared. Any questions on how we plugged any of this in? So our factored would be 3 times a plus 4b times, almost, because we have to square both the a and the 5. 5a times 4b is going to be 20 ab plus 16b squared. So we get this here. Any questions on any of this here? Any other questions on 12, 14, or 15? We good with these here? 15? Now, there's not a greatest common factor between these three here because, well, a and a squared don't have any numbers with it, and the 6 doesn't have a variable. So we do 2 sets of parentheses with 3 spaces. Since this third term is negative, our signs are opposite. What are the factors of a squared? And 2 and 3 and 1 and 6 are the factors of 6. Which one do we want to use? Which one goes where? 2 and 3. And if we check it, we would have negative 3a plus 2a is. And that would be at there. Questions on this here? Questions on 16, 17, or 18? Pretty much. They're just reiterations of ones we've done already. Any 19, 20, 21, or 22? I mean, these are still pretty much the same with some greatest common factors. Y'all want to look at 22? Okay. See if we can take the cubed root of 31,250. So we can't take the cubed root of it. Well, if we can't take the cubed root of the first one, we definitely can't take the cubed root of the second one. Because that would really kind of mess things up, because I can't take a greatest common factor out of one number without taking out of the other. Now, looking at these two here, there is one greatest common factor I know for sure. 2. Because they both are even numbers. So I could factor a 2 out. I would also factor out a y, because it needs to come out. So if I divide both of these by 2, we would have 1, 5, 6, 2, 5, x cubed minus 4, 6, now these both here are not divisible by 2 because one of them ends in a 5. 5, 6, 12, 13, 14, 19. So they're not divisible by 3, but let's go on and try to take the cubed root of these numbers here. (15, 6 to 5). And we take the cubed root of it. So this here would be 25x, which is good news for us because it also means that the cubed root of 46,656 is 36. So we can take the cubed root of these here. So we have 2y, parentheses, 3 spots, and 5. Now our signs are going to be the same, opposite, always end on a positive note. Now our first term was 25x. So here we would have 25x. Here we're going to have 25x squared. Our middle term would be 25x x, and then our last one would technically be 25x to the 0, which is 1. Our second term is 36. So we'd have 36. Nothing with the 25x to the second power. The middle one, we'd have 36x, or 36 to the first. And last, we'd have 36 squared. So if we simplify this, we'd have 2y times 25x minus 36. Now 25 squared, 625, 625x squared, plus 36 times 25, 900x, plus 1296. And this right here is your answer. So any questions on these here, on this one here? It worked out, but we had to pull out 2y first. Any questions on any of this here? Any questions on 23, 24, 25, or 26? So this here we have 4 terms. So that means we're going to have to use factoring by grouping. Now, the way that we group any of these here is fine, but I'm normally going to stick with the first 2 together, second 2 together, and look for a greatest common factor. So when I look at 25v cubed and 5v squared, I'm looking for a greatest common factor between them. Well, that would be 5v squared, because 5 can go into both 25 and 5, and v squared can go into both v squared and v cubed. 25 divided by 5 is 5, and v squared, yep, plus 1. So we're factoring out 5v squared, which leaves us with 5v plus 1 inside the parentheses. You got it right the first time. Plus 6, because 5v plus 1. And with that, we do have 5v plus 1 in both. So we can factor it out, which tells me that I have 5v plus 1 times 5v squared plus 6. And that there would be it. Now the v squared, the 5v squared plus 6, we might need to just take a second look at it and make sure it doesn't factor any further. Because if the degree is greater than 1, there is a chance that it could factor. But since we only have 2 terms and it is plus in the middle, it's not going to factor. If it was minus, we would look to see if it is a difference of perfect squares. But here it's not, because it's not a difference, it's a sum. So we're done. Any other questions on 25 or 26? Which brings us to 27 and 28. How many terms do we have in either one of these here? 2. So most likely doing 2 sets of parentheses is out. But is there a greatest common factor between them? So I can factor 12x squared out of both terms. 12 out of 12 is 1. X cubed, pull x squared out of it, I'm left with. Well, the 12x squared is the only thing that has a power greater than 1, yes? Well, it's factored out. There's nothing else with it. So that can't factor down any further. Can anything inside the parentheses factor down any further? No, because it's to the first power. So that's it. And I mean, we can do the same thing with the other one. Because we can factor a 15x out of both. which would leave us with x plus 2, which would be it. Any questions on these here? Let's do one more just because. I mean, I'm not doing this for any reason in particular. Let's say x to the fourth plus 2x squared plus 1. Let's see here. Let's see if we can factor this. Since the third term is positive, the signs are the same and they match the sign of the middle term. So we say plus and plus. Let's look at the factors of 1 first, which would be, now the factors of x to the fourth.
X squared and x squared.
Because we do have x squared and x squared, we could also say x times x to the third. And that's really it that we have. But what's our middle term? X squared, yes? So this here won't be a case. And let's see if this works out. X squared times 1 is x squared. 1 times x squared would be plus x squared, which is 2x squared. Inside each one of these parentheses is, what's the degree? 2. Well, we have x squared plus 1 and x squared plus 1. Well, it's not a difference of perfect squares, so we couldn't go any further. But if it had been minus for both of these here, these had both been subtraction, well, x squared minus 1, isn't that a difference of perfect squares? And x squared minus 1 is a difference of perfect squares. So we could technically factor that again. Not saying that this would show up as a bonus or something like that, but just thought that'd be interesting to do. Any other questions on any part of the review? I will say for certain that there are not going to be any that are not factorable, like on the homework where you could not pull out a greatest common factor, kind of like these two here or some of the others. And some of the ones that just have a greatest common factor, it's not going to be like the ones where we have a squared plus 2ab, where we have a quadratic left over, a full quadratic with 3 terms. It should be pretty straightforward, or you can see that after factoring it out, you're done. And then the rest we'll consider the cubics, difference of perfect squares, and our other factoring. Any questions on this here? All right.